Hi guys, today we're going to be talking about volume and surface area. What I need you to do is get out a pen and highlighter. You also need your STAAR formula chart and the STAAR review flipping out with volume and surface area worksheet. We're going to start with the formula chart and specifically with the volume section. If you look down here at the volume section, you'll notice that we have a big B in several of the formulas, and you need to know that big B actually represents the area of the base, which means what we are doing is taking a trip up to the area section of our formula chart. When you have a three-dimensional figure, you're going to identify the shape of the base, which is going to be one of these. You're going to find the area and put it in for big B. We also need to look at our surface area section, and you'll notice that not only do we have the big B here, but we also have a big P, a capital P. And the big P represents perimeter of the base. So if you would please write those things in for me, that would be great. Again, what you're looking at when you have big P is that you identify the shape of the base, and then you find the perimeter of it and substitute that number in for big P. Now please remember that when you go up here to circumference, circumference is just a fancy name for the perimeter of a circle. Okay, so right now that's all we're going to do with our formula chart. So if you would please set this aside and get out your worksheet. And you'll notice up here in the box we have a few of the reminders here, and it says don't forget to make changes to your formula chart when you get your STAAR test booklet. So on Tuesday when you get your STAAR test booklet, the first thing you need to do is go and look at your formula chart and make some of those adjustments on there so that you remember what big B and big P mean. Okay, let's start with number 1. It says a company plans to design a new version of its Millennium doll that will be larger than the old version. The figure below shows the dimensions of the box for the old version of the doll. If all the dimensions of the box are increased by 2 inches for the new doll, what will be the total surface area of the new box? So I'm looking for my total surface area, and I know that all of the dimensions are being increased by 2 inches. So the very first thing I need to do is increase my dimensions by 2 inches. So here, instead of 10, it will be 12. Here, instead of 6, it's going to be 8 inches. And over here, instead of 18, I'm going to have 20 inches. Now, when I have a net, which is essentially a three-dimensional figure that has been kind of unfolded and laid flat, when I have a net, the easiest way to find the surface area is to take the area of all of the different shapes and add them together. So I'm going to look at one rectangle at a time. So I want to look at this rectangle there, and that rectangle has a length and width of 8 and 12. And to find the area of a rectangle, it's going to be 8 times 12, or 96. So that rectangle has an area of 96. I also have this rectangle down here that matches it. So I'm just going to fill in a 96 there. Now I also have a rectangle on this side, which I'm going to highlight here. And that rectangle has a length and width of 20 and 8. Because this side is also the same as this side when I fold it together. So 20 times 8 gives me 160. And if I look carefully, I see that this rectangle over here is actually the same size. So that is also 160. Finally, I have the rectangle, the larger rectangle kind of here in the middle, and this one over here which matches it. And the dimensions of that rectangle are 20 by this side is 12, So 20 here, 12 there, and 20 times 12 is 240. So this one is also 240. So now that I found the area of all of the rectangles, all I'm going to do is add them all up. So 240 plus 240 plus 160 plus 160 plus 96 plus 96. That gives me 12. 9 plus 6 is 15, plus 6 is 21, plus 9 is 30, plus 9 is 39. And now I have 5, 6, 7, 8, 9. So altogether, I have 992 inches squared, because we are talking about surface area, so this is a square unit. Okay, so down here we have a grid, and we need to put our answer in. When you're putting your answer in, you need to be careful to make sure that the decimal gets in the right spot. So right now my decimal is at the end of my number. So I'm going to write 992 in there, and I'm going to fill in my bubbles that match. I do not have to bubble anything else. I can put zeros in the blanks, but I don't have to, so I'm not going to do that right now. All right, let's move on to number 2. Number 2, Andrew has a cylindrical glass that is 6 inches tall and has a diameter of 3 inches that is completely filled with water. He drinks 75% of the water in the glass. What is the approximate volume of water remaining in the glass? So I'm looking for volume, and I'm also looking for the water that is remaining in the glass. So if he drinks 75% of the water in the glass, then 25% is what's remaining. So now I'm kind of done with this sentence. I'm going to cross that out. So when I'm doing this, I have 2 steps here. I need to find the volume, but because I'm looking for only 25% of that, I'm then going to divide by 4, because if I divide by 4, that'll give me 25%, or 1/4. So let me draw a picture, because this one doesn't have a picture, and it's a good idea whenever you don't have a picture to go ahead and draw one in. This is 6 inches tall, and it has a diameter of 3 inches. Okay, so now my formula for a cylinder, for the volume of a cylinder, is area of the base times height. But remember at the beginning I told you that you have to take the big B out, the area of the base, and put in the area formula. So instead of a big B, I'm going to have the area of a circle, which is pi r squared times height. And pi is 3.14. The radius, since the diameter is 3, the radius is going to be 1.5, and I have to square that. And my height is 6. The height, remember, is how far it is between each base. All right, so now all I'm left with is some multiplying. So I've got 3.14. 1.5 squared is actually 2.25 times 6. And in the interest of saving some time, I'm going to assume that you can multiply this out. And we're going to get somewhere around 42 inches. And this is cubed because we're talking about volume, so it is a cubic measurement. Now, this represents the entire cylinder. The 42 is the entire volume of the cylinder if it was filled completely to the top. The problem is he drank 75% of it. We only have 25% left. So now I'm going to have to do 42 divided by 4. To get what we have remaining in the glass. And that is 10.5 cubic inches. Now the question says, what is the approximate volume? Well, 10.5 is pretty darn close to 11, so that's my answer. Okay, let's move over to the back. Mr. Barber wants to have the entire roof of his house replaced. A drawing of his prism-shaped house is shown below. So here's our drawing here. It says the cost of replacing the roof is $2.10 per square foot. What will be the cost for Mr. Barber to have the roof replaced? So if I am listing out my steps here, I'm going to draw my thought bubble. The first thing I have to do is find the area of the roof. And the second thing I need to do is multiply that times the amount it costs per square foot, which is $2.10. Okay, so let's look. The shape of the roof here is a rectangle. I'm only looking at this top part here. And that rectangle has a length of 55 and a width of 16. And to find the area of a rectangle, it's 55 times 16. And 55 times 16 is 880. Now you'll notice that that's one of our answer choices here. But all we've done is find one side of the roof here. So we know that's not the answer. Now, I have another side of this roof that I can't see. This 880 only represents this side of the roof here. And so I'm actually going to have to multiply this by 2 to get the opposite side, the one that we can't see. And that's going to give me 1,760. Once again, this just represents the area of the roof. My second step was to multiply that by the cost per square foot. So now I have to take this number and multiply it by $2.10, or I'm actually going to take the 0 off and make it a little bit easier. So 2.1. And my decimal moves over. And now my answer is $3,696. Okay, and finally, let's look at number 4. Number 4, the paperweight shown below is in the shape of a square pyramid. What is the volume of this paperweight? Okay, so I need to look at my formula chart, and my formula chart says that volume of a square pyramid is equal to area of the base times height divided by 3, or actually, some of you may see it as 1/3 area of the base times height. I prefer to use this one, so I'm going to be doing that. So I need to find the area of this base, and this base is a square. So to find the area of a square, I'm going to do side times side, so 6 times 6, which is 36, times the height of all of it, which is 3 3/4. I'm actually going to change that to 0.75. And then I still have to divide that by 3. So now I'm going to look at this, and I can see that my 36 and my 3 can reduce. So 36 divided by 3 is 12. So what I essentially have now is 12 times 3.75. So I'm going to come down here and work that. And I have 2 decimal places, so that moves down here, and my answer is 45, which is C. And that's all we have for you today. So good luck.